So we're going to discuss something called Rolles' theorem, which is a pretty basic theorem about the way functions behave and our use of the derivative to help us find something out about that function. So, well, here's the theorem. It says let f, the function, be a continuous function on a closed interval a to b, and differentiable on an open interval from a to b. If f of a is equal to f of b, then there is at least one number c contained in a to b such that f prime of c is equal to 0. Well, what are they really saying right here? Let's take a look at a graph where this applies. Here's a function, and we're saying, all right, let's look at this interval, let's say from 0 to 4. We know that the way the function is written here, that f of 0 would be equal to 0, and f of 4 would be equal to 0 as well. So this is an ideal interval for which to say on the interval from 0 to 4, we have a continuous function. It is the kind of function that just has a nice, smooth, continuous curve. And f of x is defined on this curve in such a way that on the interval from 0 to 4, its derivative exists. It's differentiable. So f prime is defined here. Okay, so what could we say about this function? Well, the Rolles theorem tells us that if f of a is equal to f of b, and it is, and it's a continuous function on a closed interval from a to b, and differentiable on the open interval from a to b, there exists one number c in a to b such that f prime is 0. So looking at this graph, well, it looks like there is certainly a point where we have f prime equal to 0. Now, I'm not exactly sure what value c that is. Rolles' theorem doesn't tell us where it is. It just says that we're guaranteed in this function to find some number c in between 0 and 4 where that happens. Now, the function must be continuous and differentiable on the open interval. Right here is an example where this is not necessarily the case. If we have 2 points a and b here on the function, this particular function from a to b is certainly continuous. However, there's a problem at the point 2 right here, because if we go up to this value right here, this point we would find would be a point where the derivative is not defined. That being the case, we would have to say that our Rolles theorem does not exist. It's important that the function be continuous on the closed interval, check, but also differentiable, right? Also differentiable on that open interval. F of a has to equal f of b, so there's a number of things that have to be filled for this to work. Well, let's give it a concrete example here. Let's verify for this function f of x that Rolles' theorem will apply on the given interval from a to b, and show that there is a point f prime of c equal to 0. So what do we have to do? Well, the first thing is to show that this function is continuous. Well, certainly it's a polynomial that is defined on the interval, right? F of x is everywhere continuous here. And that is an important point. The function has to be continuous everywhere on the interval. In this case, it's everywhere continuous even outside of this interval, but this function is continuous on the interval from -2 to 4. We know that because a polynomial is the kind of a function that is generally continuous over an interval. So the next question is it differentiable? So we look at its derivative. F prime of x, in this case, would be 2x minus 2. And on the interval from -2 to 4, there are no points where f prime becomes undefined. So we can say that f is differentiable as well. That's an E differentiable on the interval. So we've got a function that is both continuous and differentiable on the given interval. The next condition is that f of a is equal to f of b. So let's take a look at f of negative 2. F of negative 2, that would be negative 2 squared minus 2 times negative 2 minus 8. Of course, that's the same thing as saying 4 plus 4 minus 8, and we know that ends up being equal to 0. Let's see what happens at f of 4. In this case, taking 4 squared, subtracting 2 times 4, and subtracting 8, sure enough, that gives us 0 as well, right? 16 minus 8 minus 8, that's 0 as well. So f of a is equal to f of b. The function is differentiable and everywhere continuous. So the next question is, where on the interval does the function equal 0? So we want to verify that that's true. Well, there has to be some point c where the derivative is equal to 0. And so if we were to put that value of c into our derivative, 2 times c minus 2 would equal 0. And if we solve for c, we find that c equals 1 is a point that is in the interval from negative 2 to 4 where the derivative is equal to 0. So we verify that Rolle's theorem is true for the given function.